Let's talk about generative AI. Generative AI is a technology that has been adopted faster than any other technology in our lifetime, faster than the internet, electricity, and even smartphones. The forefront of that adoption was led by a company called OpenAI, which released a product called ChatGPT in November 2022. ChatGPT's popularity soared, and by November 2023, it had over 20 million downloads. Quickly, other AI products were introduced by major technology companies like Google, Meta, and a large investor in OpenAI, Microsoft.
In January 2025, a major new force in AI called DeepSeek, which was released as a free AI-powered chatbot, surprised the world by its claim that it was developed in less time and with less resources than previous generative AI tools. AI seemed to have arrived in the collective conscious overnight. While AI is an umbrella term covering everything from generative AI to robotics to natural language processing to predictive AI to deep learning, it is generative AI that has caught the imagination of the masses. Generative AI, which is a type of machine learning model, can respond in a natural, conversational tone. It can answer any question and provide a variety of response formats. From bulleted lists to essays to the Eisenhower matrix and even computer code. Generative AI can also be used to create music, graphic images, audio that sounds human, videos, and even deepfakes, like the deepfake Dr. Kapp who opened this video. That wasn't the physical Dr. Kapp, but a digital clone. These rapidly evolving generative AI capabilities have opened opportunities that have almost every organization buzzing with possibilities and considering possible dangers and implications for society. On the one hand, AI can help reduce the time to create marketing copy, training materials, and company documents. On the other hand, generative AI has run into issues with copyright infringements, data privacy concerns, discrimination, bias, hallucinations, cyber attacks, and energy consumption. Technology companies are buying up nuclear power plants and are locating data centers at power production facilities to draw as much power as they can. Generative AI models consume a great deal of energy.
In this video, we'll cover the basics of generative AI, its history, how it works, applications of AI, and its potential impact on organizations. We are still in the early stages of fully harnessing generative AI's potential, but its development has been decades in the making.
One of the earliest generative AI systems was Eliza, a chatbot created by Joseph Weizenbaum in 1966, who was at MIT. Eliza operated by recognizing patterns in text input and responding based on predefined scripts, but it lacked real understanding, context, and flexibility. Over the years, AI research progressed, and by the 2010s, advancements in artificial neural networks and deep learning allowed AI models to automatically parse text, classify images, and transcribe audio with greater accuracy. A major leap came in 2014 when Ian Goodfellow introduced generative adversarial networks, which enabled AI to create realistic images, synthesize voices, generate music, and even produce human-like text.
This fueled both excitement and ethical concerns, as generative adversarial networks made it possible to create hyper-realistic deepfakes, like me, raising issues about misinformation, identity fraud, and digital manipulation.
Then in 2017, Google introduced the Transformer neural network architecture. At the time, it was a breakthrough in natural language processing. Transformers revolutionized AI by enabling models to process language more efficiently using a mechanism called attention.
This mechanism called attention allows AI to analyze relationships between words and phrases in a highly effective and efficient manner. This breakthrough led to a massive leap in translation, summarization, and content generation.
Google's BERT, introduced in 2018, was another leap that improved pre-training methods for understanding language context. While OpenAI's GPT models, starting with GPT-3 in 2020 and advancing since then, demonstrated unprecedented fluency in generating human-like text. The release of ChatGPT in late 2022 brought generative AI into mainstream conversations, making it widely accessible for personal, educational, and business use. Since then, AI has advanced at an astonishing pace. GPT-4, Claude, Gemini, DeepSeek, and other large language models continue to push the boundaries of AI-generated text, images, and even code. Open source models like Meta's Llama and Mistral have sparked discussions on democratizing AI, while multimodal AI, such as GPT-4v and Gemini 1.5, allows users to interact with AI through text and images.
The rise of real-time AI assistants, personalized learning tools, and AI-driven content creation platforms is reshaping industries including education, business, and entertainment, as well as many others.
It helps to understand the difference between generative AI and traditional AI. Traditional AI is rule-based, designed to perform specific tasks within a defined set of parameters. It relies on structured data and pre-programmed algorithms to analyze information, classify data, and automate repetitive processes. Think of a chatbot that answers frequently asked questions by pulling from a fixed database or a decision tree, or an AI-powered recommendation system that suggests products based on past purchases. Traditional AI is highly effective at executing predefined tasks with precision, but vary from those specific tasks, and it can derail the entire system. Traditional AI also lacks the creativity or adaptability to generate new content beyond their program scope. It's time-consuming and difficult to program traditional AI. Generative AI, however, is different. Rather than simply analyzing or classifying information or pulling from predefined databases, it actually creates text, audio, images, and video based on predictions and patterns. Generative AI uses advanced machine learning models, such as deep learning and transformers, to generate content. Unlike traditional AI, which follows rigid rules, generative AI is capable of producing content that mimics human creativity. An example would be a tool like ChatGPT, which can write essays, draft emails, or even generate poetry, as opposed to a standard AI, and it's all without any special programming knowledge. The person just needs to type in a prompt in their native language, and the response appears quickly from the AI. In fact, it can be so quickly that it feels like an actual conversation. But how does this happen?
The answer lies in patterns, probabilities, and training on vast amounts of data. Generative AI works by analyzing massive data sets, books, articles, images, and more, to learn how words and visuals typically fit together. It doesn't think like a human, but instead, it recognizes patterns and relationships within language or images.
When you give it a prompt, it uses these learned patterns to predict the most likely and relevant response based on its training. For text generation, AI uses a model called a neural network, specifically one designed for language processing, like GPT, Generative Pre-trained Transformer. This model breaks down your prompt and considers all possible words that could come next. It then selects the most likely words based on probability, one after another, until it forms a complete sentence that sounds natural. The process is similar to how your phone's autocomplete suggests words as you type, but much more advanced. It can construct entire paragraphs while maintaining coherence and meaning. For images, generative AI uses a different type of neural network, such as diffusion models or generative adversarial networks, which have been trained on millions of pictures. When you type a prompt like, "Draw a futuristic city at sunset," the AI doesn't pull a pre-existing image, but instead creates a brand new one by assembling shapes, colors, and textures in a way that aligns with what it has learned about similar images. It generates pixels and layers, refining the details until the final image looks like something a human might have drawn.
Generative AI is becoming increasingly accessible to enterprises, small businesses, and academic institutions at all levels, thanks to emerging innovations like chatbots and AI agents that can be tailored for diverse applications. This means that various organizations can benefit from generative AI's capabilities.
Businesses can leverage AI-powered chatbots to enhance customer service and technical support, as well as generate personalized email responses. Manufacturers can integrate data from cameras, X-rays, and other metrics to detect defective parts and diagnose root causes more accurately and cost-effectively. Financial services can analyze transactions within the context of an individual's history to improve fraud detection. In the education sector, generative AI can transform learning experiences by automating content creation, developing adaptive tutoring systems, and generating personalized study materials for students. AI can assist educators by drafting lesson plans, summarizing research, and even creating interactive learning modules. Additionally, educational interactions can use AI-driven analytics to assess student performance and provide targeted interventions. Other industries are also leveraging generative AI in innovative ways. Law firms can draft and interpret contracts, analyze case evidence, and suggest legal arguments. Pharmaceutical companies can accelerate drug discovery by identifying promising candidates for new treatments. Architectural firms can rapidly prototype and refine building designs, while gaming companies can generate game levels and content faster and more efficiently.
As AI continues to advance, its impact across business, education, and beyond will only expand with both positive and potentially negative results. As mentioned before, the highly realistic nature of generative AI output, combined with its lack of transparency and questions about plagiarism and energy usage, presents several challenges. AI-generated outputs may contain inaccuracies, unintentionally plagiarize existing content, reinforce societal biases, and produce misleading or fabricated information.
Additionally, without proper safeguards, AI models can expose sensitive data, violate privacy regulations, and be exploited for cyberattacks. The significant computational power required to train and run these models also raises concerns about environmental impact. Ultimately, if the reasoning behind an AI-generated outcome is unclear, relying on it without scrutiny is risky. To responsibly integrate generative AI into organizations, the organizations must work to promote accuracy, transparency, and ethical use. Clearly label AI-generated content that impacts employees and customers to maintain trust and accountability. Verify the credibility of generated material by cross-referencing sources and ensuring proper attribution to avoid copyright violations. Recognize that bias and discrimination can be embedded in AI models and take proactive steps to mitigate them. AI-generated code and content should be rigorously reviewed using dedicated validation tools to prevent errors and security vulnerabilities. Additionally, the energy consumption of AI deployments needs to be considered and addressed.
By addressing these challenges, organizations can leverage generative AI effectively while minimizing risks, ensuring compliance with legal and ethical standards, and fostering responsible innovation.
A balanced approach, one that embraces AI's capabilities while mitigating its limitations, will be key to its successful adoption across industries.
The depth, speed, and adaptability of generative AI's responses to text, image, and even multimodal prompts, combined with its rapid and widespread adoption, suggest big changes in how organizations process and create information and content. At the same time, there are a number of concerns related to misinformation, bias, energy consumption, and ethical usage.
As AI platforms continue to evolve, their impact will continue to extend beyond standalone generative models, embedding AI capabilities directly into the software and systems we use daily. Such as the iPhone 16, which was the first iPhone to be designed around artificial intelligence, released in September 2024, and into course development software, learning management systems, customer management systems, and logistics software. These tools, with generative AI, will become more intuitive and context-aware. Design tools will seamlessly integrate AI-generated recommendations, and training platforms will automatically identify best practices across an organization to enhance employee learning at scale. This ongoing integration will streamline workflows, enhance productivity, and drive innovations across industries.
However, the next frontier of AI evolution goes beyond generative AI. The advent of agentic AI means that AI is poised to take automation to a new level. Unlike traditional generative AI, which passively responds to prompts, agentic AI can autonomously plan, execute tasks, and make iterative improvements based on feedback and real-world context.
This means AI won't just generate content or suggest edits. It will actively analyze data, make decisions, and optimize processes without constant human intervention. Imagine an AI driven training assistant that not only generates learning materials, but also monitors employee progress, adjusts content dynamically, and identifies knowledge gaps in real time. In business operations, agentic AI could manage supply chains, schedule projects, or even act as an AI powered research assistant capable of conducting multi step investigations and drawing insights from diverse data sources.
AI holds much promise, but also a high degree of peril. We must all know and understand how AI works and what it is capable of creating. The more humans can educate themselves about artificial intelligence, the more it can be used as a tool for good.